Okay, so we are now looking at production and operation management, and in particular, we'll look at the first topic, which is called forecasting and forecasting techniques. All right, now I'll be very, very slow to explain forecasting as the first topic that is in this course, POM, which is the production and operation management. Of course, like I mentioned, there are only 6 topics that you need to understand as you look at this course. Very interesting course. All right, so now in forecasting and forecasting techniques, we have a number of things that we consider, okay, in this technique. So first and foremost, we have to look at what is an independent variable and what is a dependent variable in forecasting. So here we use regression, of course. We look at our x. Our x is our independent variable. So this is a variable that can exist on its own. So independent, okay, variable. And then we have, so this variable can be, example, advertising. Okay. So advertising is an independent variable. Okay. Then we have also the other variable, which is the y variable, is called the dependent variable. So this one is dependent. So what we are trying to say here is that this variable depends on our x variable. Okay. This could have come even as you looked at if those were doing quantitative method, which is QM. This comes under a topic called the regression and correlation analysis. So if you have never sold before, or if you didn't sell yesterday, didn't have any sale yesterday, which means that even for today, it may be difficult for you to sell. So we look at the historical data for us to have a forecast for the next period. Okay, so historical data to focus on the next period. So sales will depend on advertising. Have you advertised for a product for you to make a sale? So you look at the fact that maybe you're advertising more, but the sales are still reducing. Are you spending more time advertising, but the sales are still not improving? So that measures the relationship now between your advertising and your sales. Okay. All right. So this is about on forecasting. All right. So this is about forecasting. So an example, X can also be advertising or time. Time is independent. Time does not depend on anyone. If you cannot do your masters now, you discover that when you are 5 days or 7 days or 8 days, will regret that, okay, I would have done it by the time I was 40 or by the time I was 50 or by the time I was in my youth. Okay, by the time I was a youth. So time will keep on going. Time is independent. Time keeps on going. It was 7 hours, it's 19, 20 hours or so. All right. Then your enrollment will depend, for an example, why can be enrollment will depend on it. Do you have the available funds for you to enroll for a product, for a program? All right, so this is what happens. Now, the second aspect here that we should look at is on the correlation. In fact, before this, we have what we call the regression line that we should consider after we identify X and Y. So we should look at the regression line. Now this line is given by Y is equal to our alpha plus the BX. So what are we saying here? Our alpha is the intercept. So this one is the intercept. And then we have the beta here, which is the slope. Okay. So this is the slope of the regression line. Please take note, excuse me, take note of this. From here, we now look at how we find our B. Some these formulas are given. So it's a summation of XY, then minus the summation of X multiplied by summation of Y over N, and over summation of X squared minus summation of X squared over N. This is how you find, this is what we call the slope. Okay. Then the intercept, which is our alpha, is equal to Y bar minus B X bar. So that's the formula here. For real, we know that our Y bar is equal to summation of Y over N. Our X bar is equal to summation of X over N. So this is the way we need to identify and sort out the alpha, for as long as we know that our line for regression is actually equal to our alpha plus the BX. All right, so this is the line that we need to go for, please. Then we have the aspect where we look at the correlation coefficient. Correlation coefficient. Now, this one measures the relationship between two variables in order to determine if we have the negative or the positive relationship. So this one is given by R. The formulas are given as we look at this course. So this measures just the relationship. Are you spending too much time studying, but you are not passing the exam? Or are you spending more time studying and you are passing the exam? So the more time spend studying, the more you should expect the result. Are you spending too much money advertising, but your sales are still not picking up? So this is just about what you need to know. So our R, which is the given by summation of x, y, then minus summation of x, then multiply by summation of y over n, then over the square root, okay, summation of x square, then minus summation of x square over n, so over n here. Of course, can just can present it this way. R is equal to summation of xy, then minus summation of x multiplied by summation of y over n over the square root of summation of x square minus summation of x square over n. So this is it, one parameter here. The summation of y square minus summation of y square over n. So this is it on this one. But of course, I'll be able to explain to you on this one how to use the calculator so that you don't panic too much in an exam as you do this one. So now, R measures the relationship between two variables. So make sure as you advertise more for a product while you're doing this important topic, the first one, for every organization, is that you need to know that as you're advertising for a product, you are working for a bank, you have a certain product, okay, or you have a certain account that you need people to open, you should advertise to say this is a good account, it's very cheap. Why? As you advertise more, you need more customers that should come and open an account for that bank to grow, in short, to go forward, to be a going concern. Even when you're selling chickens, if people don't know that you're selling chickens, you need to go there and start advertising. We sell chickens at home for this amount. Or what you need, you're doing business promotion. So now you look at it, this R, this is the significance of R. As you advertise more, are your sales still reducing? So if it is negative, it means you're spending more money advertising, but people don't need your service. People don't need your product as much as you are still advertising. So if it's a positive one, meaning that it's okay, meaning as you advertise more, your sales are also rising. Your sales are also going up, which is good for business. All right, so now we have what we call R squared. This is the coefficient of determination, not of correlation. So this one is called the coefficient of determination, which measures the variability in the dataset, coefficient of determination. Okay. So as we know about this, these measures the variability in the data set as can be explained by the slope. So this one measures what? Variability, not the relationship. So this one, please, measures variability in the data set. Okay, so measures variability in the data. Okay, so in the data set, as can be explained by the slope, okay, of the regression line. The slope is denoted by what? The slope is the beta. Beta is the slope. Then this one is the intercept. So this is just about what we need to go for as we look at this important topic, which is called forecasting, the first topic. All right. So there are a number of techniques that are used in forecasting. So the examiner will just determine which one among the three can come. The first one is for regression, the one I'm from explaining. So we can have one for the regression. And then the other one we should have is the one for moving average. So we have moving average. Then the other one that we have is on the exponential smoothing. So these are the only three components that we need to consider. So exponential smoothing. So these are the three techniques that we use as we look at forecasting. So in forecasting, so the first one that we are looking at is on regression. So by virtue after finishing this topic, we need to make sure that we understand these three techniques that are supposed to be used in forecasting as we get to this topic in detail. So for the regression and correlation is the one I'm from explaining right about now. So regression and the correlation analysis, okay, is what I'm from explaining now. So we can now get to an exam question paper. This came in the most recent exam, which is for November 2022, the last year. Please take note of these formulas. These formulas are given. The examiner will give you the formulas, but also the most important thing to understand is the aspect of X, which is an independent variable. Of course, also getting down to the other parameter, which is a dependent variable. By virtue of understanding these two variables, then you will not make mistakes. It will be very easy for you to understand and apply formulas, because if you just swap the two, then meaning that you will not get any mark. If I swap X for Y, then it is just obvious that you will not get your marks. So this is just the regression equation or regression line that we have. Then we also need to find how we are getting our B, this B, and how do we get our alpha. And there's a breakdown, like I mentioned, just a recap, how you get your B. You use this formula for beta, which is the slope, and then alpha, you use that one. And now you get your Y bar, And of course, how you also get the X bar. So this is just about what we use as we go. Then the regression equation, this is an equation which is given by that. Okay. So this is an equation. So what we need to do here is that we really need to find the relationship between the variables, which is given by this one. Okay, so we have this one as the relationship. Then we have also the coefficient of determination, which measures the variability in the data set, as can be explained by the slope, the regression line. Then these are the three forecasting that we need. So now we can get down to the problem. All right. So as we get down to the problem, we are simply saying we have this question. This came as question 2 of the exam, from this exam paper, the most recent exam. The first part of the question was on inventory. For those who missed inventory management, don't worry, we'll still get back there. This came on 10th November 2022 as an exam. So question number 2 was on forecasting. The first question was on inventory. Then we have this question 2, where we are saying this company, whatever the name, needs to estimate the sales of the 30 series, however, for 2022, the most recent 6 years of the revenue data for the company line of the company series and those of the smartphone industry. So industry smartphone, shown in the table. So they have the year, then you have the hour, 30 series sales and the smartphone industry sales. Okay, we have this one. So now here we have to be very, very careful to determine which one should be our X and which one should be our Y variable. All right, but of course we have 3 parameters: the year, the hour series, and then you have the smartphone industry. Now the question says, assuming that the hour P30 series sales that above represent the representative of the sales expected next year, use the time series regression analysis to focus 2022 sales revenue. There is no seasonal effect. It is 10 marks. So here, they actually want us to find the sales revenue for next year. But which comparison are we looking at? The sales revenue for next year, meaning that we are going to use the year and the company, the however P30 series company. So meaning this and this for now, for the first question. So we're using this and this for as the first question. And the other question, part B, we have to be very, very careful when looking at what the examiner is saying, assuming that the however, whatever the name, this company, P series data are representative of the sales expected next year. Use the time series regression analysis among the 3 analyses that I actually mentioned to focus for 2022 sales revenue. So meaning that the year and this company, that is for the first one. The second one, the same, perform another regression analysis between the annual sales revenue of the hardware, okay, and the smartphone industry. So they are between this and this one, between this one and this one. So this is for the second one. So meaning you are supposed to identify between these two, which one will be X and which one will be Y. All right. So meaning in an industry, the whole industry is independent because you are just getting this company as a sub-component of the company. It's more like this one is a subsidiary company, a small company operating within the industry. Okay, because this company sells phones. Okay, you have these phones here, the name by that name, and then we have a smartphone industry. That is for the whole industry. This is where this one belongs because it's part of the smartphone industry. So this will be our X for this one. For B, this one will be X and this one will be Y. For the first one, this one will be X, this one will be Y. This is just about what distinction, what differentiates the other one from the other one. So for the first question, we want to focus for the next year, which is 2022, but we are supposed to make sure that we know that this is our X, which is the year, and this is our Y as we go for this one. Please take note of this seriously. All right, then. So the first one we are going to look at is finding the focus using this company and the year. So I was trying to find the focus for the next year. Okay, for the next year, and then the same. Use the time series to focus for 2022. What will be the focus for 2022? So we are using the historical data for us to find the forecast for the next period. All right. So what is happening here is that we get to perform the first solution here where we're saying our X is the year, which is 1, 2, 3, 4 up to 6. Why am I saying up to 6? Because this is year 1, take it year 1 through to this one. So 1, 2, 3, 4, 5, 6. That is where the 6 is coming from, please. For that one, because you're saying perform using the year. We want to find expected year for the year. So the year is an independent variable. Like I mentioned, that you're supposed to identify the X variable, which is independent variable, and then the Y variable, which is the dependent variable, as we look at forecasting and forecasting techniques. All right, then. So we get down to the solution here. X is 1, 2, 3, or the Y is the how. Okay, this company here, we have this one. You just will come through and say you have this one. Then finishing up this table. Okay, we are going to have XY, meaning multiplication of these two to get the XY column. X square column, you square the X, you get that. The Y square, you square the Y, you get that. This is just about what goes on as we are looking at this kind of problem. All right, so now from here, you can find the beta, which is the slope. So this is, like I mentioned, this is the slope. You can find the beta. Of course, for those of the calculator, you can enter the data in the calculator without a problem. You just have to clear the memory. I will explain to you how you enter the data in the calculator. Clear the memory first of all, enter the data, or you can do it manually like the way we have done it. Then you get these values, substitute these values in the equation where you're finding the beta. Okay, like here, the XY summation, 580 X multiplied by Y over N. These formulas are given. You don't have to panic for the formulas. Then from here now, you're getting down to B. Our beta is giving us 8.0229 after substituting and simplification of this, after simplifying this kind of expression, you will get our beta using just what we have here. There is only X as a number of years and Y as a dependent variable. X is independent variable. Then we just simplify. Then we're getting down to this. We're getting our beta is 8.0229. And then from here, you can get our alpha as the intercept. So our intercept for this one is actually getting down. As we get to the intercept, we are getting to Y bar minus BX bar. So we can substitute here and get the values that we need. So our alpha is 20.9333 minus that. So meaning we are getting this. So from here, we are getting our alpha is negative 7.14667. This is just about our alpha that we have gotten. Then our regression equation is given by this. We substitute from the way we have here, because we have our y is equal to alpha plus bx. So b is the slope, so alpha plus bx. So this one, we know for sure that we have it, so we can actually sort it out. So for this reason, we can now get down to the other parameter. Y is equal to negative 7.1467 plus 8.0229x. From here, you can substitute now, as we're finding the forecast for 2022. 2022 is based on the on the 7th position, because there are years that from here we have been given up to, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Then 2022 will be actually the 7th what? The 7th position. So this one will be on point number 7. As we look at this, we can just now go and sort it out and put the 7 in that expression. So we are getting our sales forecast for 2022 is given by $49.0136 million, because all that we have been given, they were in millions. According to the question, these were there were millions here. These figures on top present millions. Oh, yes. So now we can now get it down to the other parameter as we get into this. Please, don't spare the question. This one came, as I can explain, again, as I mentioned, came as an exam for just most recent November 2022. So please take note of the forecasting question we're looking at as a first topic in production and operation management. So let's get down so that you see. Now, here for the first one, you took the year as an independent variable.
Sorry.
Yes.
Sorry to interrupt. I've got a question. I think I'm left behind when we found the alpha bar. Is it the X bar, the 3.5? Where did you get that one?
Which one? The X bar? Okay, all right then. So let me explain where we got that one. But from the regression for B, the formula is here. I'm sure this one you are okay with it, not so?
That one I'm okay. Yes.
Okay, no problem. So now when you're getting the Y bar, it means the mean of Y. So Y bar simply means it, like I mentioned here, first of all, I can show you something. I mentioned that when getting the Y bar, it's a measure of Y over N. Then when getting the X bar, it's a measure of X over N. It's more like you're finding the mean of Y and the mean of X. So getting down to this one,
Okay.
So getting down to this one, we are finding the mean of Y. So meaning Y bar, it is just a summation of Y divided by our N. So meaning summation of Y, we can get back here where we're getting summation of Y is 125.6 divided by how many they are. There are 6 of them. The N is 6, 1, 2, 3, 4, 5, 6. So it's a mean of this. Then the X bar is a mean of Y, the mean of X. So meaning when you're getting down to this, you simply say our Y bar is 125.6. Okay, so 125 0.6, then you divide by 6. So it will give you the answer. Then now X bar is equal to summation of X, which is 21, then you divide by 6. So this is where the 3.5 came from, in short. I'm sure
Thank you.
I've answered your question. So when you just say 21 divided by 6, you're getting the 3.5, and then the other one. Then you can come and substitute here. The B is the one that we have already found here. Then you can find the alpha, which is electric, that one, and then substitute these figures in the regression equation. Then you are able to find the regression line based on the first one, so which is this one. So from here you can find the forecast for 2022 based on the 7th year, because we came from the number of years that are listed here. They are 1, 2, 3 up to 6. Then 7th is for 2022. If today ask you to find the forecast for 2023, you can count how many years they are from there at the beginning, where they started from, then getting down to 2023, that will be on the 8th year. Then that is what we substitute in the regression equation for you to find the forecast, the sales forecast for that year. Because these are sales. Now using a year, and this for the first one. So here we are using the X is the year, okay? And then the Y is the dependent variable. I mentioned here that you are supposed to identify X is independent. A year does not depend on anyone. Years will keep on going, yet you are not improving in sales for the company or in your well-being as a human being, for your life or for anything else you're doing in business or in your sales, you're not improving. So this is it. The year, this Y is for the sales. Okay, for which one? For this company. All right, that is for the first one. That is why we did year 1, 2, 3, but don't put this, just put the year 1, 2, 3, 4 up to that. Then the other one, this one is for this company. This will be our Y. The whole industry company is the X, because this one is part of the industry. So as you are talking about banking industry, and then in particular you talk about Zanaco. Zanaco will be Y, because Zanaco will depend on the banking industry. It depends on the industry. So this is about how you go for this kind of question. All right then. So here we are also performing another equation line, but of course this time around you are going to use the industry as X for this one. So this one will be X, and then this one will be our Y. And then from here, you can now sort out this problem. So we are getting now down to this one here, where we're simply now saying our X is industry sales. Then the other one is for the other company coming from within that industry. So we are getting to this one where we're saying X is this one for the industry. So the industry is X, where we are getting these okay, as X, and then Y is this one. Then from here, we can now start doing the calculations similar to the one we did earlier. After this, we substitute using the formulas that are provided. This one, we find the slope by just doing a manual computation of what we have here. Of course, at a later time, I'll be able to explain to you how you use a calculator so that you can just get all those answers that are found within the calculator. If you enter them, then you'll be able to compute anything else that you need. All right, so we now get down to this xy, x squared, y squared, and xy. So we can find the value. So here we're saying our beta is 2.59173, but this is coming because we have the data here, computation of this. You multiply this, do this manually, x squared, this column, these are standard columns, there are 5 of them, 1, 2, 3, 4, 5. Please, for those who may be behind, let me know if I'm too fast so that I can slow down a little bit. Or are we together? Are we together?
We're together.
Okay.
We're together.
Feel free. It's a very, very important course, this one, production operation management. It's not as cumbersome as other courses because there are only 6 topics that are examinable. So you just need to follow through as we discuss. Where you have a problem, take it easy. Feel free to ask any question you want. You can ask. So you have the x, the y, the x square, the y square, and xy. So from here, you can build up a little bit and find whatever it is that we need to do. All right. So x, y, x square, y square, and xy, we are getting down to this. So we substitute in the formula here. These formulas are given. So just a matter of substituting, we got these values. X, y came from here. Okay, that is what we have there. Okay, so we have the xy. Then we got the other one. So after that, we got the figure for the slope as 2.59173. Then after that, then we're supposed to substitute there, find the y bar, the mean of y, the x bar, the mean of x. Then our alpha was negative 12.1544. Then the regression equation is given by negative 12.1544 plus 2.5917x. Then from here, we are supposed to find the forecast for 2022. So the forecast for 2022 actually is supposed to substitute that here they gave us that find the forecast for 2022. Given that we have the all industry sales for X is 20.9, substituting X at 20.9 here. So substituting 20.9 in this kind of question, we got $42.012 million. Now, here they are actually now asking us for us to do the last part of the question, where they're saying which independent variable between the time between this one, forecasting, or this one be. So which independent variable should this company choose for its 2022 excuse me, forecasting of the sales revenue? Be quantitative, 5 marks. So what is happening here? We need to find the one which gives us the correction coefficient higher or the coefficient of termination higher. So we need to go for the one that will give us the higher coefficient of correlation, number one, and then the higher one that will give us the higher the coefficient of determination. So this is just about what we need to go for. All right. So now the coefficient of determination we supposed to calculate based on part C. So coefficient of coefficient when time is the independent variable as it is for the first one. So after substituting this one in this formula, using the first data, the first component when time was independent, when the year in fact was independent. All right, so we are using this data to find our R when it was like this. So substituting in this kind of problem, we are getting our correction coefficient gave us the 0.983 of substituting using the first information that when time was an independent variable. Like I mentioned here, that we have the independent variable and we also have the dependent variable. All right. So here we are simply saying our time when time was independent, we are getting our correction coefficient is 0.983, meaning that it was still a positive relationship. When time was going And sales were also increasing as per, that's what it means, because it's very close to 1. All right, so this is 0.983. Coefficient of now the coefficient of termination R square is 0.966289, which is the square of this, which is 96.7%. Now, getting down to the other parameter where we are looking at the coefficient, for the second one, the correlation coefficient when all industry is independent, because like I mentioned that an independent variable is a variable that can exist. It will be there on its own. All right, like time doesn't depend on you. This is a time you need to do your masters, do it. It's a time for you to sell it, sell whatever you want to sell. Time will not depend on you, please. So when the oil industry, the first one, we had oil industry, independent variable. Then the other one was time was an independent variable. So we have two different kind of independent variables here. The first one was when time was independent variable, and then the other one was when oil industry was an independent variable. Then we are to find the coefficient of termination. So the R here has given us the 0.99 after computing it using this formula, which may look cumbersome, but it's not. I will just show you how to use this, how to use the formula. Of course, for those who did quantitative method, this is just not a new topic. So forecasting, and you see actually bounces back in POM, which is production and operation management. So we get now the one which has a higher, the one to use now. You check this one is 96.7, then the other one is 97.6%. So conclusion, the independent variable of the smartphone industry sales revenue. So the independent variable is used in the smartphone industry because the coefficient of correlation and the coefficient of termination are stronger as compared to time. So when time was there, it's 96.7%. And then getting down to when the oil industry was an independent variable, the coefficient of termination was actually 97.6%. So we can go for the oil industry because it has a higher coefficient of determination. So this marks the end of this forecasting and forecasting technique based on regression and the correlation analysis. Unless there are questions so far before we switch on to the other topic, one of the shortest topics also, because this one is part of what we need, okay, as you understand forecasting and forecasting technique. All right. So these formulas are given at your level. Don't have to panic for these formulas. They're given at the end of the question paper. And this came in the most recent exam that we're talking about in November 2022 for those who are doing POM, Production and Operation Management. Please take note of this question. These questions are recycled. You find that they may come in an assignment or they may come again, they may bounce back in your exam. So this is about the forecasting question we are from doing right now, unless there is a question so far before we get down to the other topic. One of the shortest topics in POM that we are going to look at. After this one, we are going to go to the other topic, which is called the master production schedule. So here in forecasting, the most important thing to understand is the independent variable for regression. Like I mentioned, I emphasize, don't swap X for Y, because if you do that, you'll find that everything else will not be correct. Because X is independent, which is advertising. Even if you haven't told you which one is X and Y, you should just know that X is independent variable, e.g. advertising. And then we also have the aspect of time. Okay, so time is also an independent variable. Sales is a dependent variable. Your passing of an exam will depend on how much time you're spending on the desk studying, or how much money you have invested in going for consultant services, for tuitions, or anything else. So this is just about you understanding which one is, and the regression line, substitute it, you get whatever you need, find your beta, find your correction coefficient, correction determination, and all that. So it is, so the other session will be able to look at now the moving average for forecasting. Okay, we'll bounce back, and then we need to get another question paper for the exam where we need to look at the moving average, and then exponential smoothing. We just have to look at the unitless papers so that at least we get down, so that we dismantle these two remaining. All right, so we will now be able to look at the other topic in the next few minutes from now. Just hold on a bit. We'll be able to do another topic, which is called master production schedule. MPS is the other topic we are going to actually look at. All right. So hold on a bit. We'll be able, in the next few minutes, we'll be able to look at the other topic. But are there any questions so far based on what we've discussed, what I've explained so far on forecasting based on regression and correlation? Are there any other questions? Are there questions so far? Or is it clear people have understood this one?
Clear.
Okay, thanks very much. So in the next few minutes, we'll be able to get to okay, we'll be able to get to the other topic, which is called master production schedule, which is the shortest topic in production operation management. So in the next few minutes, we'll go for that topic just about now.